All right, let's talk about a library that if you're in data science or scientific computing with Python, you probably use every single day, NumPy. But here's the thing. We're going to look past that familiar surface because there is a whole world of power hidden just beneath. So let's dive in.
Yeah, if you know NumPy, you know it for one thing, right? The array. It's the absolute bedrock of the entire scientific Python world. It's fast, it's memory efficient, and it's how we handle these huge chunks of numerical data.
I mean, how many times have you typed import NumPy as NP? Probably more than you can even count. It's almost muscle memory, right? It's that first step to creating those powerful arrays. But what if I told you that this little line of code is just the tip of a massive, massive iceberg?
So that's what we're going to do. We're going below the waterline. We're going to explore the hidden depths of this library and uncover some of the powerful and honestly kind of surprising engineering that really makes NumPy the powerhouse that it is.
Okay, first stop on our dive, just below the surface. You'll find something pretty incredible, a complete, professional-grade toolkit for statisticians, baked right in. And I'm not just talking about your basic mean and standard deviation. We're talking direct access to dozens of complex statistical distributions. You want to model probabilities with a beta distribution? Go for it. Need to test a hypothesis with chi-square? It's right there. It's like having an entire statistics lab ready to go right out of the box.
Let's just pick one of these as an example, the famous student's t distribution. It's a cornerstone of modern statistics, absolutely essential if you're doing hypothesis testing with small data sets. But the story of where it came from, well, it's probably not what you'd expect.
Seriously, you heard that right. One of the most important statistical tools we have was invented to brew better beer. A guy named William Gossett was working on quality control for Guinness, and he developed this method. But the brewery didn't want their competitors to get their hands on it, so he had to publish his work under a pseudonym, Student. And that's the kind of rich, surprising history that's just baked right into these NumPy functions.
Okay, time to go deeper. We're descending into the real deep, dark parts of the iceberg now, and we're going to talk about randomness. Now that sounds simple, right? Just pick a number. But generating truly random numbers at a massive scale, it is one of the most complex and fascinating challenges in all of computing. Think about it. Modern machine learning, huge simulations, they run on thousands of computer cores at the same time. Every single one of those cores needs its own stream of random numbers. So how on earth do you guarantee that all those streams are actually independent? How do you make sure they don't accidentally start repeating each other and just completely wreck your results?
Well, NumPy's approach to this problem has actually evolved. The original generator, PCG64, is fantastic. But researchers found a tiny, subtle flaw. Imagine you give a unique starting number, like a seed, to a billion different computers. It turns out there was a very small chance that the internal states of these random number generators could collide, leading to overlap in sequences. So the NumPy team developed an upgrade, PCG64DXSM. You can think of it like adding an extra powerful scrambling step at the end, which makes those collisions basically impossible even at a massive scale.
And when I say massive scale, I mean massive. This potential issue with the original generator only really becomes a risk when you're running more than 2 to the power of 29 parallel streams. That's over 500 million. Now look, most of us aren't doing that today. But for the future of large-scale AI, for these gigantic simulations, having that extra safety margin is absolutely crucial.
But here's the best part. This isn't just about being safer, it's also about being faster. Just look at this chart from the NumPy docs. The old standard MT9097, that's our baseline, 100%. The modern PCG64, it's over 60% faster. And this other new one, SFC64, is almost twice as fast. So you get statistically stronger randomness and a huge speed boost. It's a total win-win.
All right, it's time for our final dive. We're going all the way down to the foundation, the very bedrock of NumPy. We've seen the stats, we've seen the sophisticated randomness, but what is it that makes it all so incredibly fast?
This is the big secret. Python is famous for being easy to use, right? But it's not exactly famous for its speed. The magic of NumPy is that it acts as a bridge. When you call a NumPy function, you're not really running Python code anymore. You're actually triggering a gateway to super high-performance code written in languages like C and Fortran. And this really shows the two worlds that NumPy bridges. On one side, you've got a simple, standard Python loop. Easy to write, but slow. On the other side, you have this highly optimized Fortran code. Incredibly fast, but way more complex to write and integrate. NumPy is the translator. It has these amazing tools like F2Py that essentially wrap up all that powerful low-level Fortran or C code and let you call it with a simple, clean Python command. That is the core magic. You get the ease of Python with the raw pedal-to-the-metal speed of a compiled language.
Okay, let's head back up to the surface. We started this journey with just a simple array, but I think it's pretty clear now that NumPy is so much more than that.
It's way more than just an array. It's a professional statistician's toolkit packed with history. It's a state-of-the-art system for generating random numbers that's built for the future of computing. It is a high-performance bridge that connects Python to the legendary speed of languages like C and Fortran. It's a meticulously tested, brilliantly engineered library, and it is truly the bedrock of data science.
So the next time you type import NumPy, maybe you'll pause for just a second and think about what's really happening under the hood. What hidden tools are you going to go looking for? It's not just an array. It's a whole world of incredible engineering, just waiting for you to explore it.